Welcome to a new tutorial for fundamentals of programming. Today we will speak about unit testing. Um, let's see what is actually unit testing. We say here that is a way of testing the code by programmers. So actually we the programmers, the developers, have to test our code. It will be very important to don't have any problems, any errors in our code. So that's why when we write some functions or some methods, we have to test them. That's why we have here that the unit test is a sequence of the code that will test a well-defined unit. And this unit, usually it will be a function or a method. So like a programmer, when you write a new function, you have to test that function to be sure that it doesn't exist any problems in that function, and the returned result, the output of that function, is correctly calculated. Now, also regarding to the unit test is a method for developing some application. Is named test-driven development because actually this method is based on the tests. So when we start that project, we make the test. That test will fail, and after we have to implement the code in this way that the test will pass. After this test passes and the code is written, we write new test that will fail, and again we develop the code. And we say that is exactly how people think about how to do the method. So if I want now, let's make a new method or a new function that will calculate the sum of two numbers. In the first moment, in my mind, it will be the sum of two numbers. So if I will have 4 and 6, the returning value, it will be 10. So I made the test in the beginning. After that, I start to write the code to make actually this operation. So that's why we say that it's exactly how the people think about how to do the methods or the function. It is used. So for some projects, you will meet some kind of projects that are developed on based on this on this procedure, test-driven development. Some reasons that to make us to use unit test. It will be very easy to write them. So you see that from one line of code, you can create the test. It will be very easy. We can write the test once and to run them when we need them to run. So we can write them exactly when we develop that function, and after that we can test and we can check the functionality of that function more times from that moment. So that's why it will be important to test to write these tests exactly in the moment that we implement the function. Even if the test it will be sample, they can define collection with test. We'll not discuss in this course, but we can have something like test suite, a suite with a lot or with a big number of tests. So we can create this type of suite test, and also can be run it automatically every time that we need. We can create in Jenkins some jobs to run this test every day if we want. We will see in the next slides that we have a lot of frameworks that can be used to simplify this process to test our methods. Also, some more advantages. It will reduce the time for debugging the program, the code, and for finding the bugs in our program. Also, we will reduce the number of the bugs in the delivered program. So after we say, yeah, the program is finished and we send to the users, we'll have a small number of bugs. We cannot say that doesn't exist any bugs in our program. Dijkstra say that. He say that by testing, we can verify, we can find some problems in our code, but we cannot certify that there doesn't exist any errors, any bugs. So that's why it will reduce but not eliminate. And you, of course, increase the rates of bugs identified during the code is writing, because this unit test, it will be writing in the time that we develop this code, we implement these functions. We'll have some reasons also to not use the unit test. You will hear a lot of people that will say, why do I have to test my code? It's my code is written by me. I don't have to test it because I'm really sure that is correct and it's written by me. It should be correct. So I don't have to test it. You heard a lot of people saying that, but it's wrong. So other people will say, I don't have to write test. I write code. I write some improvements. I don't have me time for this. So I don't write this unit test. But it's important to write them. I say that we have a lot of frameworks that can be used. Here is only a small list. I put it here for Python. For example, we have unittest, we have PyUnit, we have CS108. So we have a lot of framework that can be used to create this test. Let's create. I will start with assert. Assert, it will be how to say, it's a keyword from Python, so it can be used without any something special or to install something. It's a keyword from Python, but the report from assert, it will not be very good or very attractive. Let's create a new code. So let's create actually a function, and after that we have to test this function. I will create a small function, add numbers. It will be enough. Numbers, and I will have number 1 and number 2, and return number 1 plus number 1. Great. So now I have to test, and I will use assert. I say that is a keyword in Python. It can be used directly without any installation or preparation, let's say. So to use this one, we have assert, the keyword, and after that I have to call my function, add, just a second, add numbers, and I have to pass the numbers 2 and 4 equal with 6. So actually here I will make the verification if this one, it will return 6. So my function should return 6, and I assert it. So let's see. Because we have a problem. Actually, it doesn't return a 6. It returns something else. My assert keyword, you will say, no, is not correct. So I have an assertion error, they say here. They will not say, tell me exactly what is the problem, what is the result that I get it, but they say that here we have a problem with this add numbers. And if you see, yeah, I put it here actually number 1 and number 1. So I have to use also number 2. So it will be number 1 plus number 2. So that's why it was a problem, because actually returned a 4 and not 6. Let's run it again. When everything is fine and the test is passed, our assert keyword, it will do nothing. So actually it will not print something in the end. Usually when we use this assert, in the end we make something like print all tests are passed. So everything is fine. Is not a problem there. And now we have this message. If I have a problem, let's make again this error. If I will have a problem, actually I will have that entire message that I will have actually an assertion error. So the test didn't pass it. I say here all tests are positive because we can put more tests. Is not a problem. So this is with assert from the Python. So we don't need something installed or something like this. It's a keyword directly in Python that can be used. Let's put the correct form. Okay. Let's go now for unit test, but I will copy this function because I want to use the same function. Let's add a new code. And also I will make that mistake to have number1 plus number1. And I want to use unit test. First of all, if you run on your machine, you have to install it. So if it's not already installed, probably I have already installed it in Colab, so I don't need to install now. What is important here, if we have, let's say, two tests, we need an object. Let's see, I will say TC from test case. Actually, let's say test. Okay, in this way. And let's make snake case. Snake case. We have test case. Here we have to use unit test. I said that test case. In this way, we create our test case that can be used to test my functions. So I have to create this object. This one is an object that it will be used for testing. So I will use this test case dot. I have a function here, a method assert equal this one, assert equal, and this function it will takes it has two parameters, so it will takes two arguments. The first one is the actual result. The actual result I have to call the function. So I will call the function add numbers of 3, 2, and 4. It's similar like here. This one is the actual result. So this it will be the first parameter or the first argument here. And the second argument, it will be the expected value. The expected value is 6. So in this way, I will check, similar like here, if add numbers of 2 and 4, add numbers of 2 and 4 are equal with 6, are equal with 6. This method will compare these two parameters. If it is everything okay, the test will pass. If it's not equal, the test will fail. So in this way, it will work assert equal from unit test. Let's run it. And I will have an assertion error. The difference between unit test and the keyword assert is that here it will say 4 is different than 6. So I don't have any, only the error. I will have also the message that what problem I have there. What I want to point also here, we have here, okay, we don't look to the self. This is the first parameter. This is the second. And we have also a message here. If I want to use my assert equals, usually we'll use in this way for the beginning, but we can put also here add numbers function is not correct. We can put and here. And actually we'll have this this personal message. I hope that add numbers, no. Here, add numbers function is not correct. What is this parenthesis? Okay, I don't need it. So we can put a message that that we want to appear there. If you want, it's not mandatory, but if you want, you can put that that message. That's why I say here we have this message that is equal with none. So with unit test assert equal, we'll take two parameters, the actual result and the expected result. So I put it here, I call it for the first argument, I call it a function, add numbers, and the expected result is 6. So that's why here you say is 4 different than 6. Let's correct the function, number 2. And if I run now, everything is fine. So in the same way, they will finish and they will don't tell us something. So I can put the same message, everything is fine. Great. So in this way, we can test with unit test. For unit test, we need this object. Is mandatory to have it. Okay. For students, we can use also CS1400. This framework is created by the University of Delaware, if I think. uh, Computer and information science. Yeah, it's computer and information science, and this code is actually the code of the course from that university. Also, this one should be installed if you want to use it. I already installed it, so I can use it. But what is important is when you have to use, you have also to import it. So I will from sys import assert equal. Okay, let's put the same function. I will test the same function like before. Here it will be more easier. It will be the same like here, but we don't have to create this object. We can directly assert equal. So we don't need any object. It will be a function. It will not be a method. Here assert equal is a method, but here is a function. And the same, the first parameter, it will be the actual result. So it will be add numbers 2 and 4. And the second, it will be the expected value, 6 in my case. Let's run it. We have now the information. Test is passive. Line 5, assert equals now, and so on, is true. Everything is fine. If it will be wrong, let's put here number 1 in number 1. So the result, it will be 4, different than 6. I have also a failure. So in this way, with this framework, we can see exactly if everything is fine. We have all of them are passed. This way, if something is wrong, we have a failure. So in this way, we can check even if it's everything correct or we have some problems. And also for this one, predicted answer was 6, but computed one was 4. So we have more information. That's why this framework is created exactly for students, and in many cases we have to use this framework because it's created exactly for us to learn and to understand the situation or the problems that we have in our code. So let's put here back to be everything fine. Great. We say that the importance of unit testing is they will help us to identify the problems. So that's why when we have some problems, I will create another, let's say, a text. I will put here debugging, and the code. Let's make something like in the previous video. I will put something like, or I have discussed it in the class today. I have a function that will calculate, let's say, f equal with a plus b or d plus c. D, here it will be c, and here it will be d, let's say. So I have this function, f a plus b multiplied by c plus d. In this way, actually, if we split the operations, we'll have something like, I will have add number function. I will use this one. And a multiply function. So I will make a new function, def multiply. I will have number 1. Oh, what are you doing? number 1 and number 2. And here we return a number 1 times number 2. Great. If you saw that mistake, I made it purposely to check actually the function, the end function, to test it. So now what we have to do to create this function, final function or something like this. So let's say def function that will get 4 parameters. So we'll have A, B, C, D. And here, what we have to do is to return what I have in this way. I will have add numbers of, I will have A, and the second one, it will be B or C. So multiply B, B. So second, here we have A, B, and C. And all of this, I will have to call again add numbers of this one and D. Great. So I will have this function. Now, what I have to do is to test. I have to test all my functions. So let's test add numbers. I will use this one. So I will copy the import to have it here because I have to use it. And now let's test. So I will test assert equals. I will test the first function, add numbers. Add numbers. Usually when you have to test a function, you have to make more tests for that function, not only one. What I created here, test 2 plus 4 equals 6, and that's all. No, you have to create more tests. Let's put actually here, we have 3 and 5, it will be 8. Doesn't work. I will copy classical way. I will have -4 and -5, it will be -9. Great. And so on. So we have to test more situation, more test cases. Also, I have to test multiply. So I will have assert multiply 3 times 5, it will be 15. And let's make a new one. 7 times 11, it will be 77, and so on. And now we have to test this function. No, I will comment them, because in the beginning probably we are thinking let's test directly the big function, the f1. So if I will say assert equal of f of, let's say I will have 2, 3, 4, and 5. I don't know exactly how much should be, so I will have 3 times 4, 12, 12, 14, 19. So should be 19. Okay, let's check it, run it. Yeah, we have a problem. Name f, oh sorry, is function, not f. Function. So let's test again. Fail, because predicted answer was 19, yes, but we get 88. So if I'm looking to this assertion, actually they say, oh, the function is wrong. The function name it function, it is wrong. Let's say operation. So the operation function is it's wrong, is not correct. But if we uncomment this line of codes, actually in this way we can see where it is exactly the problem, because the problem, it will not be in this function operation, it will be in multiply. So if I run now, test, pass, test, pass, fail, fail, fail. I have 3 failures. So I will look on that one that is use it, the operation function, it will use multiply. So that's why these 2 functions are actually the problem. So I see there that predicted answer was 15, yes, but computed was 243. And here is a very, very big number. So that's why the problem, it will be in multiply. And yes, I put it here to exponent, actually not to multiply. And now everything will be okay. Test, pass, test, pass, test, pass. So that's why unit testing, it will be very useful when we have more function to test each one. And in this way, we can find exactly where it is the problem. So don't think that the problem is in that function that call other functions, and it is possible to be in a small functions. Great. This is regarding to the unit testing. I hope that it will be helpful for you, and see you in the next video. Bye bye.